Alright, we're solving systems of equations, systems of linear equations by graphing. The main concept that we got to keep in mind when you're solving a system of equations is we're looking for a point that satisfies both graphs. In other words, it's a point that's on both graphs. So this is literally looking for the point where the graphs meet. Far too often, scholars will get a question like this and they're just going to graph the lines and say, okay, I did it. That's not what this question is asking. If they're asking you for to solve the system, they're saying find a point that satisfies both equations. And if it satisfies both equations, then it is on both lines. And if it's on both lines, it's going to be the point where these lines meet. Lucky for us on this first one, this line is already given to us in slope-intercept form. How do I know? How do I know it's in slope-intercept form? Well, it's because y is by itself. You can see right here is y equals to, and there's things on the other side of the equal sign, but y is by itself on one side of the equal sign in both equations. So let's graph the first one. The first one here, I can see that my y-intercept is 3. So I'm going to go on my y-axis and I'm going to plot that 3. Then the second one, I notice my slope, first line, I notice my slope is 1. So if my slope is 1, I know the denominator of every whole number is 1. So we get 1 over 1. So that means I'm going to go up 1 and then over 1. Up 1 and then over 1. And then I'm going to follow this pattern backwards so I can get as many dots on the page as possible. Obviously, if you have a ruler and you take your time drawing, you may need to just do 2 spots. I like to do as many as possible because it helps me to stay accurate, regardless if I have a straight edge or not. Now I'm going to graph my second line. I see it has a y-intercept, or the number by itself of -3. I'll go ahead and plot that. Boom. Now over here, my slope is -5 over 1. Okay, let me write that down. I have a slope which is going to be equal to -5. And any whole number has a denominator of 1. So normally, if I'm plotting that, I would just go down 5, and I would go over 1. That doesn't make sense here, because there's not enough space. So I know that if I'm keeping this same pattern, which is going to give me this kind of slant, I can reverse both arrows and keep the same slant or keep the same slope. So I'm going to go back 5 and I'm going to go up 1. Oh, excuse me. Total mistake. I'm going to go back 1 and I'm going to go up 5. It gives me the same thing. Notice something also. -5 over +1 is going to give you -5. And then 5 over -1 is also going to give you -5. So we're actually maintaining the same slope when we go both directions from a numerical perspective. So now, I'm going to follow that same concept. I'm going to go, and let me change the color of the line. It might be useful to see the difference. I'm going to go back 1 and up 5. 1, 2, 3, 4, 5. And look, I found a point that meets already. I can go back 1 and up 5, but there is no room. So, here we go. Does this make sense? Now, a lot of people think they're done with this question. You definitely are not. I need to state the point where these lines meet. That's my solution to the system. Well, if I'm starting from 0 here, I know to get there I had to go -1 and then up 2. So my solution is going to be -1, 2. Of course, don't take my word for it. Scroll in the packet to the end of this section and you see the solutions there where you can check. See you in the next video for another problem.